Welcome to the second day of Energy Management Systems with Michelle, and today we have Christy helping out and providing some entertainment. Next slide, go. There we go. As a reminder, you guys are all on mute, unfortunately, but we do have the chat feature enabled, so ask your questions that way. The webinar is being recorded, and there's a little survey after the class. If you take that, please. And in a couple of weeks, we're going to be having another 2-day course, a heat pump deep dive. We've done a heat pump water heater deep dive, which maybe you took, but this will focus on the HVAC technology. And of course, we haven't offered yet through DNR Learn electrification of the built environment towards the end of October. Then if you're in the area, if you're a Snohomish County PUD or PSE or Seattle City Light area contractor, there's going to be an HVAC training where you can actually do some hands-on exploration with some heat pumps. And with that, I'm going to hand it over, if I can click the button, to Michelle and Christy.
Yeah, hey, welcome, welcome, welcome. I'm Christy. It says I'm Diane because I'm taking over for Diane today. She had some other meetings she had to attend, and so I am here. I am part of DNR Learn. I'm the instructional design team manager, and so some of the content that you see presented from us, I work with SMEs to build. So today I'm your moderator, and I'm here with Michele Sagehorn from Redcar Analytics, sorry, for Energy Management Systems. Really, really thrilled to be here. I love this course. And Katie, thank you for the introduction and letting everyone know the courses that are coming up. The next one, the Heat Pump Deep Dive, is actually one that I co-teach with another instructor of ours, Lester Terrence, and I think it's really cool. It's the first half of it is all HVAC, and the second half of it is all domestic hot water, and so there's like, it's heat pumps in every landscape you can imagine. Really super cool. I helped QA/QC the electrification of the built environment course, which is also a really, really cool one. And of course, today, Michelle, I have to say, your class is actually one of my favorite. I think it's really beautifully designed. I think it's really interesting, and there's such good, like, real world examples that you can really get your teeth into it. So we're here today together for 2 hours, and so somewhere in the middle, our goal is to take a break, to stretch and to use the facilities, and then to wrap up around noon, 12 o'clock. Like Katie said, some nuts and bolts before we get running. We're going to be using the chat feature for questions. So if, as Michelle is presenting, something pops into your mind, you really want to ask it, please make sure to put it in the chat. And then as we take breaks and pauses, we'll pull all those questions out, and Michelle can grapple with them and chat about them and answer them. We're also going to be using an interactive polling software today called Slido. I love this software for a couple of reasons. One, it's technically super easy to use. You can open a web browser on the computer that you're already looking at, or you use your phone or any type of smart device you have around you to scan a QR code or go to the actual website and use a join code. But what I really like about it is that it's super, like, totally free, it's super intuitive, and you don't have to create any type of account or login for it. So as we go through this, look for those slides and polls and surveys, because we really count on your participation for these classes. You know, it adds some texture to the class, but also we use all that data to help improve our courses. So really excited about that. I think that's about it. So I'm going to hand things over to Michelle. My role today is just to hang out in the background. I'm Christy again. You'll see me pop in when we have questions, when things pop up. And I'll be adding some links to the chat for you, including the slide deck in just a second. And other than that, Michelle, the stage is yours. Thank you so much. I'm so excited to get going today.
All right, thanks, Christy. So just to check that everything looks good on the screen. We good there? Everybody seeing the presentation? Definitely welcome back, everybody, or welcome if you're here for the first time. As you said, my name is Michele Sagehorn. I'm having a little bit of bandwidth problems this morning, so I probably won't have my camera on as much, or maybe today, but like I said, welcome back, and thanks again for participating on Tuesday for all of the people who did. Just as a recap of what our agenda is on day 2, we will be doing the EMS deep dive, qualities of an effective EMS, and getting into my favorite section, the case studies. And hopefully we will continue to kind of be answering these key questions as part of this presentation of the value of the EMS, but also today I think we'll spend a lot of time on how to successfully implement an EMS and to use one. So let's go ahead and get started. We are going to do an introductory survey, so we'll get the Slido going right away. So as Christy said, if you guys could get that going, that'd be great. You have the code there, and you have the QR code and also the event code. I'll give everybody a minute. I think we have 3 questions again. Probably a basic one, just how everybody's doing this morning. But also just wanted to see if there are any new people in the audience, you know, people who maybe weren't here on day 1. And also just if there's any lingering questions from day 1 or anything specifically today that you want to learn or know or have questions answered, that'd be great. So yeah, give it a minute or 2.
I love these, not to harp on it, but I love interactive pieces and webinars, Michele, because we get a sense of like who's here today. And it's so interesting, I think, to see who joins. Every time we teach a class, we have like a new group of people with a different set of backgrounds, a different set of like experiences and hopes with this. So I hope folks, you'll log on and participate. How's your day going so far, Michele?
Pretty good, pretty good.
Any big plans for after the webinar?
Not too much. I do have, it's been, like I said, a pretty busy week, so definitely some things to follow up on. But I definitely enjoy doing this, and it's definitely a different thing than just doing the normal grind day to day. So I appreciate these classes as kind of a nice little interruption.
I have super mixed feelings about you being busy, because part of me wants you to keep just like teaching for us, and then part of me is like, yeah, go girl, your company is taking off, like you're getting tons of work, it's awesome. Any big projects you're really excited about?
Well, I have, it's funny because I do have a lot of projects that are kind of engaging in this lead version 4, and they're choosing to do, you know, this monitoring-based commission, which requires an energy management system. And honestly, it is kind of like introducing it to somebody every time. So I get a little practice of doing that in my job. But yeah, it's been interesting, kind of what people know or don't know, and just kind of really getting one into a project. So I am working on this lab project right now, and they're implementing one. So it's been interesting working with the controls contractor, and we're kind of taking the approach that we're going to kind of build something kind of custom within the BMS system to satisfy it. So that's always kind of fun because it's, you know, unique and very specific to that particular job and client.
That is super cool. I was just traveling with an engineer who works with commercial heat pump water heating systems all the time. And he was just telling me, he's like, yeah, I'm starting all these new projects and I'm like introducing people to it again and again. And he's like, low key, part of the time, I'm like, doesn't everybody already know about this? But it was a really good reminder because he teaches some of our foundational classes. He's like, oh yeah, some people don't. So we need to keep having these conversations. So it's nice to hear you say the same thing. Like, yep, that is an experience we all have.
Yeah. So I do have a question, Chrissy. I want to make sure. It looks like there's 2 people on the poll, but usually the questions pop up, so I'm not sure.
Yeah, I'm actually on the
Properly?
back end making sure it works. Hey folks, if you're trying to get on it and you're running into issues, would you mind putting in the chat, just letting me know how it's going? Let's see. So hold there, Michele, for a little bit.
Okay.
Let's see. sometimes when you toggle back and forth, oh, there we go. There it's starting to pop off. Sometimes when you toggle back and forth, it closes and it opens it again. And it takes a little bit longer on the back end. But so if you can take your cursor down to the lower left-hand corner of your screen. Yeah, so see the little arrow going forward? I think if you click that one, let's see if it, go ahead and click it. There it is. Yeah. All right, I'm gonna get out of your way.
No worries. All right, great. Sounds like everybody's ready to go though today, so let's get there. Okay, it looks like for the most part, most people were here on day one, but it looks like we might have one or a couple people maybe not, so that's fine. We're going to do a quick little recap here in a second. Let's see. As far as questions to bring today, we have best practices for the architecture of an EMS, hierarchy of points, what to include, how much to include. Okay, great questions. Let's see if we can get that answered. All right. So like I said, a quick little review. So on day one, we kind of talked about what is an EMS. And I think, you know, the takeaway I took, or what I was trying to convey, is that a lot of EMSs look and feel different. You know, the three that we showed examples of here, the state, campus, and building, they all look unique, and they're all kind of tailored for that specific client and kind of their needs and what's important to them as far as their energy management system. I am kind of curious if anybody actually poked around on any of these sites. So if you did, feel free to share that, because I'd love to see what any observations or thoughts on it. But yeah, we did take a little deeper dive into UC Davis and kind of what that looked like and how that might be effective for their campus. And then we also talked kind of a little bit about the business case for an EMS, right? Why would we need one or purchase one? And you know, there's the obvious things of obviously saving energy, and that equates to money. We know that a lot of the codes are now starting to require it. And then of course we have a lot of clients that want to do the right thing from a sustainability perspective, and they're choosing to do a lot of these certification programs like LEED that I just mentioned, and which also requires an energy management system. But I think at the end of the day, what, you know, we conveyed at the end is that I think it is a good business case. It is really cost effective with a pretty good payback, and as far as installation costs as well. So in my mind, it does make a great business case for most buildings out there. And then we did spend some time kind of talking about the difference between a BMS and an EMS, and really why it's important to understand that. And I think it's even more important in today's landscape because, as I mentioned, the industry's changing. It's changing at this moment, and we're starting to get hybrids of BMS and EMSs, and it gets more and more confusing. So I think understanding what those features are, what those tools are that are important part of an EMS system, you can then walk into any system and say, well, they may say it's a BMS, but it actually has EMS features and functions. So being able to identify that is, I think, kind of important so that you can get the most out of your system. All right, so we do have a little pause here in case there are any quick questions, but I think I'm gonna just kind of move forward, and if you guys do, obviously you can put them in the chat, and there'll be plenty of other opportunities as well.
There's no questions in the chat, so you're good to go there.
Okay, all right, so let's dive in and do our deep dive. So I mentioned, you know, in EMS, one of the most important things is having this flexibility and customization. It really is the bottom line. As I just described, a lot of EMSs look different, very unique, where if you would look at a BMS from a vendor, they tend to all look the same, or they look a lot alike, and there's not as much customization ability within those systems. And the reason customization or flexibility is important is because every client and customer is different, from their business operation to the way they actually run their building or manage their building or maintain their building. They often have different goals or different things they need to track or report on, and they're always continuously changing. So what would be some, let's get the slide going. Okay, what would be maybe some of the important qualities for a good or an effective EMS. So we've identified 4 here, and we're going to talk about each of these, from customization, data tagging, navigation, and visualization. So let's go into customization. What does that mean? Well, it could be as simple as literally putting your logo on there, right? Or changing the color scheme. It could include just putting some important information about, again, your company, or sharing just overall energy use and things of that nature. But it can be much more than that as well. And so I wanted to give an example of a tool that's being used in the industry, and you may be familiar with it, maybe it's new to you, but I kind of wanted to show how this kind of relates to customization on an EMS. So what we're talking about is fault detection diagnostics, FDDs. In California, actually, they are starting to require this on package units. And as far as kind of like more customized systems, there is a guideline out there. It's not a requirement by code yet, but there is a guideline out there. It's called Guideline 36, ASHRAE Guideline 36. It has a lot of these fault detection diagnostic already kind of pre-built for you, so they could be easily implemented into a building or an EMS. But let me go ahead and kind of walk through this example. And I know it's kind of small, so don't worry about that as far as what's on the screen. But ultimately, the intent behind a fault detection diagnostic is to be able to tell if your system is performing properly or performing efficiently. It's very different from an alarm that you get from like your building automation system, which might say a piece of equipment's broken or not working. It is, again, trying to be kind of proactive, preventative, and ultimately just kind of confirming that your system's running efficiently. So if we look at one of those, the one at the bottom there, AHU, which is air handler mixed air temperature low, the description is that the mixed air temperature should be between the outside air temperature and the return air temperature. And so what it does, it's actually very similar. On day one, we talked about analytics and analytics software and how it has some pre-built smarts and logic in it. It's actually quite similar to that. So what this does is it'll take all these data points, so our mixed air temperature sensor, our outside air temperature sensor, and return air sensor, and then it's going to perform an equation, which in this case, it's that red language there, or text. And then if it meets that condition, it's going to spit out a fault. But again, it's much more than just a fault or an alert. It's going to give you 3 things that are important. One, it'll give you the description. So in this case, of course, it's the mixed air temperature low, should be between the outside air and return air. But it also gives a recommended action and a possible diagnostics. So on the recommended action, in this case, it's saying, hey, why don't you go look at the trends of the data for at least a week, look at your return air, mixed air, and outside air sensor, and look for anomalies. And when you do that, more than likely, you're going to find out which sensor is the problem. So in this case, the diagnostic is probably a bad sensor. But which one? Well, you can, before you even step out into the field, if you took those recommended actions and took a look at the data, you'd probably be able to figure out which one it is. And so that's where this is really important and powerful, is that it's giving you kind of a direction to go look. You know, it's often really easy to identify an issue. It's a lot harder to troubleshoot and to solve it. So that's where this FDD can be, like I said, it adds that detail and possible solutions. And it's doing this before there's an actual failure. So I had another client that, like I said, these are kind of, a lot of the ones come pre-packaged in this Guideline 36, but I had a client who had a radiant system, a radiant floor. They've never had one before. And it was really important for them. They wanted to understand if the system was, you know, operating efficiently or operating per the design intent. And so what we did is we actually, you know, they asked us to help, and basically we created a custom fault detection diagnostics for that radiant system. So we put together some of these things where we told them which points they should be looking at, and you know, what are the key performance indicators, as well as kind of creating that equation, and then creating even, like, again, the description, recommended actions, and possible diagnostics. So that's where, you know, we had the ability within their systems to customize and create something like this for them, which is really important. And so they found it to be very useful. And like I said, it really helped them kind of understand how their system was operating. I also wanted to mention another client who implemented FDD across a larger campus. And it was important to them for a different reason. Essentially, how they handled maintenance calls is they had a group of technicians, and they were mixed trades, so it could be electrician, plumber, mechanical. And basically, when they would get a call that something was wrong or something needed to be investigated, they would send out whoever was available. And that person would go out and they would try to figure out what the issue was. And a lot of times they needed a different trade. So they might have sent an electrician, but they really needed the mechanical technician. So then they would have to come back and get the right person there. And then the right person would go there and they would try to diagnose it. And they might find out they didn't have the right tools to actually fix the problem. So there could be up to 3 trips back and forth before they actually got to work solving the problem. Where when they implemented this fault detection diagnostics, they were able to kind of know before, again, anybody who got deployed out into the field, what trade they needed, electrician versus mechanical. They knew usually what tool they needed, a shovel versus a hammer. And basically it became a one-trip kind of deal, which made their operation way more efficient. And that's really important because, maintenance and facility staff is usually extremely busy. So that was particularly helpful. And I would argue that it does play into, obviously, energy efficiency, right? Being able to maintain your building really is important. I mean, if we just let sensors go bad and the system's not broken, but it's not performing efficiently, then again, we're not saving energy. So maintenance is extremely important, and this is a tool that's helpful in, I think, a lot of different ways. So let's go ahead and move on. Adaptability. So this is another important characteristic of an EMS, and it kind of falls in line with customization, but it is different. It's really about the ability to change things or to change your system, because you might start off where your EMS is meant for the sustainability manager, but now, in all honesty, they're making a lot more tools out there for facility staff that are useful and helpful for them. So we're starting to see more and more of that particular client wanting to use the EMS. And so you might want to change it and create some tools for your facility staff or a different user, as well as, again, your goals may change. And maybe you want to start reporting to, instead of just, the upper management, or to maybe your staff or, people within the building as far as how you're doing. So it's, again, about having that ability to really change things. I would say a lot of times people, like when you give an EMS at the end of, like, if you implement one during a new construction project and you turn it over, a lot of people don't know what they don't know. They don't know what they need until they kind of live and work on the building for a while. And now, I've been maintaining it for a year. Now I know what would actually make my job easier or make it more helpful. And so, again, being able to come back to the system and change or add features is where it becomes really helpful. All right, next one is data tagging. So data tagging is probably kind of what you expect. It is about labeling data, but it's a little bit more than just how we label data points. Data tagging allows users to kind of organize information more efficiently, as well as associating pieces of information with it, like keywords. And ultimately, it makes searching a lot easier and quicker. So let me give you another real-world example. This happens to be one of the clients or one of the projects we're going to talk about a little bit later, Lawrence Berkeley National Lab. So the engineers were trying to do some research, and I'll be honest, I don't really know what they were looking for or what they were doing with the data, but it was important for them. They wanted to go find the supply air pressure of all of the air handlers across their campus. And so obviously multiple buildings. And what they did is they had to first obviously go out and search for the data that they needed. And what they found was, what you're looking at here is 19 different ways of labeling or tagging the supply air pressure off of an air handler. In fact, sometimes it was even different within the same building if it had multiple air handlers. So the bottom line is, what this means is it took them a long time to be able to find all this information, where if they were all labeled the exact same way, this would have been a much easier exercise. So that part's important, but again, there's more to it than that. So let's take, instead of a supply air pressure, let's just take a temperature sensor. So if I had a temperature sensor, you might label it sensor or temp or something that makes sense. But then what you can also add to it is you can add the geolocation, you can add the building, You can add the room number, and you can add, even like what it's associated with. If that temperature sensor is controlling a VAV box, or if it's an air handler, you know which piece of equipment it's associated with. So it really helps put the data in a much larger context. I'll point out that the industry is trying to kind of standardize this tagging. There's a couple projects out there called Project Haystack and one called Brick. And that's kind of what they're doing, is they're like, hey, don't just standardize your building or your campus. Let's kind of try to standardize it within the industry. So there is some guidelines out there for this purpose that can be used as reference as well. But by using tags, it really helps avoid confusion, and it creates a whole new world of analysis. It allows us to analyze data in different ways than we ever could. So looking at LB&L again as a campus, let's say if I was a sustainability manager and I had a building and I had to replace the chillers in it, maybe I want to do a little bit of research and kind of find out how things have been performing on the campus. So if I have everything labeled consistently, I'm able to search all the chillers on campus quite easy. And now I've associated some keywords with it. So another thing you might be able to find is I want to go look and find for the last year how many chillers have had failures or the most failures. And then when I do that, what I might discover is that it's all one manufacturer or one model of chiller that's causing the most trouble. And that helps me maybe make a procurement decision that I'm not going to buy or purchase that vendor or that type of chiller. I'm going to go with something that's been working really well for our campus. That's another way to look at the data that's, like I said, very unique to how we have in the past. It's not something you would typically be able to do on a building management system. And so like I said, it really lets us go a lot farther and analyze things a lot differently than we ever did before. When data is not tagged or labeled consistently, it also increases the time and cost for installation as well as integration of other systems, which, as we mentioned on day one, we're seeing a lot of integration to other systems within a BMS or an EMS. And I wanted to go back to that one example of the lighting integration into the BMS. We talked a little bit about that on day one. So just to kind of go back to it, it's another great example of data tagging. When we tend to want to now bring in lighting system into the BMS for the purpose of energy efficiency. We want to use those occupancy sensors to be able to control the HVAC. And what we get is, there's definitely a lot of work that goes into getting those two systems to communicate. However, once they do, we're able to bring in the data. It honestly, I think I said, you guys, it looks like a foreign language. It probably looks worse than the data tags that you're seeing on the slide right now. It's really just a bunch of letters and numbers that literally make no sense. And so you can imagine from an installation perspective, that's really challenging, as well as the fact that we really do need to know where they're located so we can associate them with the right piece of HVAC equipment. And if we don't, then of course this energy efficiency measure is not going to work. So it's extremely important. And then again, going a step further, as far as you can imagine maintaining a building, sensors go bad, things go bad. You want to be able to go and replace it, and you don't want to be popping up ceiling tiles or doing something invasive to try to find this and spending a day doing it, where if you simply tagged it properly, it's going to tell you exactly where to go. So it has a lot of purposes as well. All right, let's move on to navigation. Obviously, navigation is the ability to move from one place to another. But really, the way I see it for an EMS, a good navigation ability would be able to get you to the correct information or to the problem quicker. I mean, really, that's what we're trying to do here. So you're looking at the image in the center there is, again, a typical building management system graphic. And the image on the right is an energy management system. And what I'm starting to see a lot of these energy management systems be able to do is, if, let's say, we're looking at the chart on that EMS, maybe on the bottom left side, the bar graph down there, and we look at the bar that is the highest, let's call it the peak. Maybe we want to now go look at that particular day or that data point in a little bit more detail and say, well, what's going on this day, or what happened? You're able to kind of move your cursor on it and click on it, and it'll take you, to the next level of information. And then usually again and again, and hopefully it's all relevant data that is related to this initial piece of data. So another example day one, we showed a heat map in the red in the green, right? And we saw that one VAV box was always problematic. And so we want to go look at that VAV box. You would be able to click on that heat map chart on the red, and it would take you directly to that VAV box. And therefore, you would be able to say, look at it and say, well, maybe it's a damper, maybe it's the valve stuck. And again, get to the information quicker, right? So how do we know if an EMS system is good at navigation? That's a good question. And I'll be honest, it's not really easy to know right off the bat. Because of course, some systems are going to be better than others. I guess the way I would answer that is that vendors do allow you to have trial runs, and a lot of times they'll let you even poke around on real buildings, or they'll have one that you can. So you can kind of get a feel of the features and the tools that are part of it. I did have one client that actually purchased 2 EMSs so they could try them out before they kind of deployed it across their campus. That obviously is not the most efficient way of doing it. But what I would go back to is that if you have a system that is the ability to be customized and the ability to change, be adaptable, then you can always come back to this later. Again, as I mentioned, you lived with the building for a while. Now you start to know what you need, and you can come back and kind of make those adjustments to your system if it has that flexibility and customization. Okay, so visualization. Again, we're showing our favorite UC Davis one there. I mean, data visualization is just a graphical representation of information and data. You know, we're using elements like charts and graphs and maps and different things of that nature to provide an accessible way to see the data and to be able to pick out those trends or outliers, patterns, and anomalies. In all honesty, some data is displayed better in a pie chart or a heat map, for example, or a bar chart. So it can be more effective the way you visualize it. But what I would say is that data visualization is almost essential these days because we are analyzing massive amounts of data. I mean, as again, new construction buildings, we're integrating more systems, they have more data, and we just have almost too much data. So, we need the ability to be able to see it, understand it, in an efficient way, so in a more effective way, and that's what visualization does. I would ask if anyone has ever, if in their work they use spreadsheets, and look at them or work with them. I do in my job, and I can tell you when you're doing that, you might be staring at this spreadsheet and you're looking for something, a specific event or date or piece of data, and it could be right in front of you, and you just don't see it, right? It gets kind of cloudy and it just kind of all looks the same. But the minute you put it on a trend or a graph, you're like, oh, wait, there it is. That's kind of, that's ultimately what visualization is. It tells a story, but it also removes the noise, and it should be highlighting the useful information. I like to say it's storytelling with a purpose. Okay, so just summarizing here, we have, again, these are definitely important qualities for an effective EMS. Being able to customize and configure it for the users and the audiences as well as our goals. Our data tagging so that we can sort that information in a lot of different and meaningful ways. Navigation, again, being able to get to the useful data quicker, and then visualizing, again, also helping us get to it quicker and tackle our goals and problems. Okay, so we spent a lot of time talking about EMS and the different looks and feels. And I think through day one and in today, we've talked about a lot of the tools that are typically part of an EMS. What I wanted to do is take at least a moment on this slide to share with you what I think are some of the tools that are almost in every EMS. Like they're kind of like standard, regardless what vendor or product you might purchase. These are definitely some of what I would call the basic tools that should be part of a basic EMS. And so, of course, the ability to track energy use and identify inefficiencies. Being able to benchmark your building's performance, and hopefully, again, in a visual way so you can identify areas for improvement. And then performing measurement and verification. So again, if we want to implement an energy efficiency project, the ability to track it, confirm the energy savings, and I'll hopefully also be putting a dollar amount to it. And then incorporating some data quality verification diagnostics, some things that are running behind the scenes that will alert you if things aren't working properly. From, again, our temperature sensor maybe going out of range to anything, but ultimately letting you know that the data that you're actually getting is good data. That's also important as well. And like I said, these are what I would call some of the basic tools. And of course, from there, there's a lot more that can be added or even customly built as well. All right, so I thought it was also important to take a moment to talk about things to avoid. Unfortunately, I do see a lot of EMSs out there with, things that are just meaningless comparisons. I recall one where they somehow put energy into hamburgers, and I still am baffled by that. But it was just kind of silly, and I wasn't really sure what that meant, and it surely didn't give me anything that was insightful or actionable. And that's really what we need, because that's where the change happens, is the ability to act on something. So a good example of this is I had a car that I used. I do a lot of traveling to and from job sites. So I had a used car that I had, and the dashboard would always, I'd always get this warning on my dashboard, and it would say that my tires had a low air pressure, but it didn't tell me, what tire it was, didn't tell me how low or by how much, didn't give any other information. And I'll be honest, most of the time I just ignored it. Eventually that car I ran its course, and I had to go purchase a new one, which was painful, but I did. And I've had that car for a while now, but a similar event occurred not too long ago. And, I got this alert on my dashboard, but this time, again, it's new car, a lot of bells and whistles. And so it said, your right tire was low. So it told me the exact tire. It told me a percentage, like 18%. And it went so far to say that's below the recommended tire pressure. It may be unsafe to drive. So that's like real data. That's real information that you can act on. Like maybe now I decide I'm not going to drive my car today. I'm going to take public transportation, or maybe I'm going to work from home. But it's something that I have the ability to, like I said, make a decision on. Where just getting that other tire alert was just really a useless annoyance. And many dashboards share information that just unfortunately isn't useful, rather than giving us clear insights and direction. And I think when that happens, they can overwhelm us with too much noise, and they can definitely obscure what's important. Also create confusion and sometimes raise needless questions. Instead of being empowered with actionable insights, we ultimately just land up kind of ignoring the data completely. So that's definitely something we want to avoid. All right, so we are going to go ahead and pause for a minute here and see if there's any questions so far.
Yeah, there's nothing in the chat. So folks, remember, if you've got questions, feel free to write them down, and during our pauses, we can check in. If you also want to report them to Slido, we'd love that too, but I feel like the chat is a little bit easier during it. So nothing yet, Michelle?
All right. Okay.
I have a question though, actually. I often do. After looking at all those real world examples, which one of them do you think, can I say, like, is your favorite? Do you have one that stands out in your mind and you're like, they really nailed it, like, this is awesome?
Well, honestly, the data tagging is fairly new to me. I'm trying to think when, I became knowledgeable of it. It really wasn't that long ago, and I was just really impressed by, like, just again, the ability to really sort and compare and make these comparisons of data that I never even thought about or even thought were possible. Like I said, a lot of clients sometimes will now take attendance data and compare it to comfort complaints, and they'll just use it in different ways that I was like, wow, like, and it becomes a lot easier to do that and simple. And so I thought that was really powerful. It's something, like I said, that's kind of newer to me. So that's definitely something that stands out to me.
Cool, thank you.
Sure. All right. We'll go ahead and move into, I believe, our next section here. So what makes an effective EMS? I mentioned that just because you know have an EMS, it doesn't mean you're going to be successful. You know, I think sometimes people think that they're just plug and play, and they're not. They're not typically as plug and play as one would think. You know, it definitely requires input from the owners or the users of the system. So this is what I would say are the two important things to make this EMS effective. We need to develop it for the intended users, and we need to define some key performance indicators. So we're going to cover both of these, and we'll start with the intended users. Okay, so this is just a couple people that may use an EMS, right? We have our energy managers, which we're calling our reporting users. We have our facilities personnel, that is maybe our sophisticated user, and then we also have our building users or occupants, which we'll call our new users. So I think when you look at this, you know, each one of these users are going to look for different types of data. You know, they're not going to probably all be interested in the same thing. So that's one thing to note. The one thing I would say is common between all three of these users is that we need to have actionable insights for all of them. And so how do we do that? Well, let's talk about that. So we have our first one, our reporting, our energy managers. So typically a sustainability manager, you know, they're typically responsible for more than one building, and they tend to need to look at things at a very high level because some of their responsibilities include reporting to upper management. Most of the time they are responsible for setting as well as tracking and, you know, evaluating how they're doing against their sustainability goals. And then again, a lot of times they have a budget, and they're the ones kind of deciding where to spend that budget as far as energy efficiency projects on the campus as well. So they're going to be looking for some very specific things that are different from our other users. So how would we make an EMS actionable for this particular user? Well, we have our chart up here from UC Davis again, and I hate to keep going back to it, but I really like this one, especially from a campus level, because as we mentioned, we are seeing every single building on campus there, and just by looking at it with the circles around it, we can tell which building is using the most energy. And I think it's just really powerful because you can immediately then go to that particular building or decide, you know, this building needs some upgrades, that's where I'm going to spend my budget. It really is helpful there. So that is one way to make it actionable for them. And I think the example I just gave regarding kind of like looking at the data tagging and looking at the chillers to make a procurement decision is another good example of how to make something very actionable for this type of user. If we move on to our sophisticated user, our facilities personnel, as you guys know, as I've mentioned many times, they're usually very, very busy, juggling a lot of different things. They can be internally staffed or they could be outsourced, but ultimately they are usually looking at the data to kind of do some troubleshooting or fixing issues. But they also are usually responsible to help the sustainability manager with managing and maintaining the sustainability goals or evaluating them and making fixes to make sure they stay on track. But again, they're also responsible for managing and maintaining the building functionality, comfort, concerns, and so on, and making sure the equipment keeps running. So they have a wide range of duties. And so again, how could we make something actionable for them? Well, I think probably the best example is that fault detection diagnostics, right? Really giving them some real useful information before they even step out into the field, making it, again, easier to get to the problem and quicker to be able to fix it. So I think that's a great way of making an EMS actionable for this user. And yeah, I also think the heat maps are great too, because that's one where they can look at their whole building in one chart, you know, all the VAV boxes, all the reheat valves, all the whatever could be on one chart, and you can get a good sense of what everything's doing, or if there's a bad zone or zones within your building. All right. Okay, and then our last one here is our building users. I think this one's one that's often overlooked, but extremely important because they really do play the largest role in how buildings use energy. So how would we make it actionable for them? Well, we need to give them some important information that might impact their behavior, right? Turning off the lights, opening, closing windows, or managing all your plug loads. So an example of this is I had a client who they were implementing natural ventilation. They had operable windows, and when the outside air conditions were ideal. They wanted them to basically open the windows, and they actually did shut off the HVAC system. So how did they get that information to them? They happened to be a software that was kind of their business. They developed software. So they created their own little tool, but ultimately it was like when people would log into their computers for that day, they would have this little widget that would sit at the top of their screen, and it was either red or green. So green, obviously, hey, open your windows, ideal conditions outside, versus red, don't do that. And I think it's just, again, really important to get them involved in that, but also even sharing how the building's performing. I have another client that was trying to get net zero, and they created on their EMS kind of this little, kind of more of a dashboard where they were providing just some great information. One, how the building was performing and if they were on track, but also kind of how they were getting to net zero. They also gave kind of a description of how the systems work and why they selected them. And again, it really gave a better understanding of how the system worked, but what it really did was it engaged them, and it created some ownership and better understanding. And they also would put on their course some things that they could do from a behavior perspective. Like they would explain, like if you had these receptacles, now there's the controlled ones and the uncontrolled ones, and one of them is connected to an occupancy sensor, right? So if you left your desk for 10, 15 minutes, it'll turn off, certain things that are plugged into that receptacle versus the other. And I know that this comes up a lot. A lot of times people are like, well, what do I plug into which one? And so that's an example of where they explain it in great detail to the users of the building, so they understood and they set it up properly, and where it was actually managed their plug loads the best and most efficiently as they could. All right. Okay, so let's go ahead and, so we've talked about developing for the intended users. Let's talk about the KPIs, our key performance indicators, which ultimately are just measurable metrics that are important to the client. Okay, so if you're going to have a KPI, I would say that it has to have these three things, right? It has to be important to the client, it has to be measurable, and it has to be actionable. How do we do that? Well, a lot of clients don't know. I mean, we do have some that are very sophisticated, and they have like their campus standards, or these are the things we're going to track and measure. But there's a lot of clients out there who've never built a building, or they just don't know and they need help. So that's where, again, a lot of good consultants come in, and it could be anyone from an architect, engineer, commissioning agent. There's lots of people who can provide a lot of help around setting metrics in the early, phases of a project, and that's where it's really important. How do you do it? Well, I don't know if there's the best way I know is really just asking a lot of questions. We often will have these kind of meetings where, working meetings where we kind of just ask a lot of questions. How are you going to use the facility? Are you looking to monitor one facility or multiple? What do you really need to do? Is this going to be used to make purchasing decisions, or is it more for reporting? Are you planning a plant expansion? Basically to understand, again, what's important to them, and then making sure we have the right things to be able to measure it, of course, and then hopefully provide it in a way that then they can make some action based on that. So I'll go ahead and give you guys an example of a bad KPI and then maybe a good one. One of the things that I see all the time out there is during a project, usually the owner needs a little bit of help. So a lot of times the engineer will help provide an energy goal. And what I see out there is in California a lot is they'll say something like this: we want our building to be 10% better than the California Title 24 Energy Code. So I would ask you, do you know what that is? I don't know what that is. Is that a real number? It's not a real number, because at the end of the day, all buildings, different square footage, different orientation. Typically, you're going to use an energy model to kind of confirm the code compliance from an energy perspective, and that's where they get those numbers from. But it's not a real number. It's not an EUI, like an energy use index that we talked about in day one. And so it's not measurable and it's not actionable. And so that's something I just see so much, and I generally will always call that out. But then on the flip side of that, what's one that's good? I mean, obviously I mentioned EUI. That's a real number that can be measured and tracked. Another example would be, somebody who's going for net zero, right? We know what that is. It's pretty straightforward. We need to produce more energy than we consume. that's something that most people can understand, from the contractor to the building facilities staff to the commissioning agent to the occupants within the building. And that's what we need to get to, is something that's easy to understand and, again, measurable and actionable. Okay, so now we have an exercise here, guys. We're gonna get you again, get you involved in. And so we're gonna ask you to go to this website here. There's actually two websites that we'll put into, or two links that we'll put into the chat, and basically ask you kind of to just poke around and look at it and make some observations. You know, look at those reflection questions. You know, what are the KPIs for this particular client? And how are maybe the KPIs similar or different? Maybe just kind of what are your observations that you see from this particular client? And then, of course, we'll have a little Slido poll afterwards to get everybody's input. And we will do, again, about 10 minutes for this exercise. So if we can, we'll come back at about 11 o'clock, and I will go ahead and put myself on mute. All right, as you guys are kind of wrapping up, I got the poll up there and activated, so feel free to kind of enter any of your observations at any time. All right, well, we're waiting for anyone. Oh, here we go. What are some of the key performance indicators for these institutions? With greenhouse gas emissions, energy consumption, water use. Yeah, absolutely. One, I guess a couple observations I saw was that there's a lot of them. Definitely, you're looking at a more sophisticated user. Two, they're definitely tracking things beyond just energy. Waste, water, some very specific kind of climate goals. I think there's even like transportation on there, like how their employees are often they're traveling and by plane and things like that. So there's a lot of interesting stuff on there. The one other thing I wanted to point out, and I don't know, this changed maybe from the time we started teaching this class, but you may not have caught this, but when you're looking at some of those charts, you might see something below it that says Tableau. I just wanted to point that out. It's a software program, and there's multiple out there, but this particular software program is just something you can purchase. And if you have somebody who knows a little bit of, I don't even know, you don't really need to even know programming, but ultimately it's pretty user-friendly to be able to create and customize these visualization, these charts like this. So they're doing this on their own. And I think the reason they kind of went to this Tableau, it's my understanding, is because they wanted the ability to change and to customize, and they didn't really want to rely on anybody else. So yeah, that was one of the other things I wanted to kind of point out to you guys, is that this page or these pages are kind of constantly kind of evolving, and they have that ability to make that adjustment. All right, let's see if we got anything else. Oops. Okay, how are these KPIs similar or different? They're all important for meeting sustainability goals, but they look at, sustainability through the lens of different resources. Yeah, that's a great comment there. I definitely agree with that. All right. One last slide here, I think, before we go to break. So yeah, I wanted to just kind of talk about kind of, again, the red car process when we're creating KPIs, what we do with a client. Again, it really is, we do kind of have this little kind of template of questions we ask them, but again, it really is about just asking questions with the client, understanding their needs, their desires, what's important to them, and then being able to put it into action and make sure we have the right, again, equipment and sensors and so forth to be able to measure it. Okay, so one last question here, sorry. What would you guys, if you were dealing with a client, how would you help them, build an effective EMS? What would be a question that you might ask them? So yeah, if you guys want to participate really quickly, that'd be great. We are gonna, like I said, go for a break. So what I'll say is, why don't we come back at like 11:14, and we'll resume.
I think that sounds like a great idea, Michelle. And we have one question that's waiting for you. So I think when we come back, we could probably address that question too.
Okay, perfect.
Okay, 11:14. We'll see everyone soon.
All right, Christy, I am back. You said you had a question for me?
Yeah, there's a question from one of our attendees asking, can you talk about the type of maintenance required to keep an EMS going?
Okay, yeah, that's a good question. So when I think of EMS, so a lot of times there is, I will say that this is probably not my area of expertise. As we get into a lot of these systems, there's definitely a lot of IT stuff and things to consider, security, things of that nature. But some of these softwares, they do have, kind of their scheduled kind of upgrades and maintenance that typically happen. And I think on day one, I mentioned that there's a couple different ways you can kind of deliver an energy management system. You can kind of just buy it and manage it yourself. You can actually have the vendor kind of host it on the cloud, and they would kind of do the maintenance that's kind of required as far as the database. And then, of course, you can do the whole, as I mentioned, the third thing usually being the full service, where they not only maintain the database and so forth, but they also kind of help kind of identify issues and maybe do some of the reporting for you. So there's definitely different ways it gets delivered. Sometimes you can kind of offload that to somebody outside if you want. That might be an easier solution for some clients. And then if you're going to do it internally, I would say, one of the things that I always do is I always get the IT people involved, understanding what they need and kind of like security, like I said, VPN access, all that kind of stuff, and what it means to them hosting it on their network. And sometimes there is issues with this. It really isn't an issue anymore, but kind of the amount of data, being able to store it, and how long you want to be able to store it for. But that's gotten to be where it's almost not a problem anymore. But there used to be issues where it would bog down the system, make it slower, or you couldn't store data for much longer, a long period of time, where maybe you want years and years worth of data. So that kind of has gone away. I'm not sure if I answered everything there, but yeah, I think the actual software kind of thing is more of a kind of an IT thing, where there's definitely maintenance that's required from, again, like sensors and things like that, but in the hardware that maybe is kind of pulling the data in for you. But hopefully, again, if your system has some of those features, it should identify when a sensor or device is actually kind of out of range or out of typical range, which might also indicate that there's a problem or it needs to be repaired or replaced.
Awesome, thank you. That was the only question we've got so far.
Okay. All right, and it looks like everybody got in some great questions that they would ask clients. So thank you very much for your participation there. And let's go ahead and move into, I believe, our case studies here. Okay, so the first one is a project I worked on. This is a library. It's located in Half Moon Bay, California, so it's really close to the ocean, pretty mild climate. It was completed in 2018, and that's when they opened to the public as well. It's pretty small. It's 25,000 square feet. It's 2 stories. They obviously had a really strong sustainability desire in this project, so they achieved LEED Gold. And they also had, they designed the building to be able to achieve zero net energy. Now in 2018, I said they went into operation. So for several years, unfortunately, they did not achieve that. And that's what we're going to talk about in a minute. But to give you a little bit more about the building, I did want to point out that a little bit about the mechanical systems in there. Definitely very unique. They have in-slab radiant heating only, and they have a ton of stuff that they've integrated. They have natural ventilation with some automated windows. They have heat recovery ventilators, and then they're also integrating their electrical meters, their lighting. They have automated shades. I mentioned the windows already, and they also have these ceiling fans that are tied into their system as well. So quite a bit of technology kind of put into this little tiny building, a lot of complexity. And they actually have no active cooling. They do what's called a night purge, where they basically have the automated windows open at a specific time. They turn on the fans and kind of suck in that cold outside air and kind of pre-cool the building. And they do that by kind of looking at the weather forecast to see if it's going to be, hot in the coming days and so forth. So that's kind of how they do the cooling there. My role on the project, I was involved in it as a commissioning agent back in the construction phase. And then about a year ago, the client reached out to me and they said they wanted some help, or they needed help because they really, really wanted to get to the zero net energy. And they, as I mentioned, hadn't been able to quite get there, although they weren't too far off. So we started working with them, and this is the first screen here I want to show you. This is actually what they are calling their EMS. The way this came about was the decision to add this EMS happened really, really late in the construction phase, which is a little unfortunate, but ultimately they did decide to incorporate this into their building management system. So here's a good example of it being all in one, location. They had the controls contractor kind of custom build this. And one of the problems, though, was because it came so late, there wasn't really a good process to kind of understand who's going to use it, what information is important. We weren't sure if this was going to be displayed in the library lobby for the public, or if this was actually for their facilities and building engineers. So, there was just a lot of like, I'm not sure what to put on here. So the controls contractor kind of just did what he thought. He tried to ask a couple questions, and this is ultimately what he came up with. As you kind of look at it, I'm guessing you guys can probably pick out some things that maybe don't look right, don't look wrong, maybe missing, not very useful. I would say go ahead and, as I'm talking, stare at it and kind of see if you can point some of those out. And I'll just kind of start rattling them off. So one of the things I would say is if you start from the left top there, you'll see the main electric demand real time. So we have that, and then we have our kWh current day average and our kW current day total. Again, it's not that that's bad information. It's not, but I would kind of argue, what do you do with it, or how am I performing well or not well? It's definitely not something that you're going to use to kind of track if you're on course to achieve your zero net energy. It needs to be displayed in a different way. So then if we move right below it, you'll see the same thing over again, but this time it's for subpanel 1 and then subpanel 2. So I would ask the question for this one, well, what is subpanel 1 or 2? Ultimately, on this project, they had their loads segregated at their electrical panels, and they did submeter them. And so, I'm not sure, though, if that's the HVAC panel or if that's the lighting panel, who knows? So that's not very helpful at all. In addition to it, they have more than just 2 subpanels, so there's just some of them are plain missing. They are also tracking some water usage there, which is fine. It's more informational, but again, I wouldn't say there's anything really actionable there. And then right below it, you'll just see some floor temperatures, building first floor, second floor average floor temps. They added this basically because they've never had a radiant system and they weren't really sure what to look at, and they wanted to make sure it was operating properly. But ultimately, again, I don't think that this particular graph is telling them any useful information. And so the last thing I'll say when I point this out is, if you can tell there's something really serious missing, and that is we don't have our PV or our photovoltaic information on here at all. So we have no idea what that system's doing, if it's producing enough energy to meet our goal, just completely not on here. So again, not probably the most useful for tracking zero net energy. So as we got together, we met with their facilities engineers, who they do have an internal team. They obviously run multiple buildings, but it was their internal team. And we worked together where each month we would meet. And what we had to do was actually pull the data for them and kind of present it. So this is an actual, I don't know, I think this is in, it might not be Excel, but anyways, we literally kind of custom made this or manually made this. We had to go pull the electric data from the BMS, and we had to pull the PV data from the PV system separately and obviously put it on a chart. So this is our kind of our high level tracking for zero net energy. The blue is the energy consumption of the building, and the yellow is the PV production. And so there's a couple things missing on this chart, but I'll maybe try to explain it. So as you're tracking net zero, you obviously, it's a 12-month period, right? Because one thing you'll notice is that in December and January, the energy consumption of the building was higher than the PV. That's very typical, right? In the winter, we have less daylight hours, and therefore we don't get as much out of our solar systems. So in order to really achieve zero net energy, we have to be actually tracking the accumulative amount. I like to say it's money in the bank. So back in June, if you just look at June, you are going to say, well, I'm doing good because I actually produced quite a bit more solar than I did, energy I consumed. But you need to produce X amount above what you consumed. Like I said, put it in the bank for when December and January come around, so that we have enough surplus to cover those periods of, not as much production. So we also were keeping a kind of a cumulative running average of that. And then one other thing that's not on here that we did need to kind of incorporate into this is not just the actual data, but if possible, if you can get what are the predicted amounts. So what is the predicted energy use? We typically might get that from a building energy model. And then for solar production, there actually is a tool online that's accessible to anyone. It's called PV Watts. And you can go there and kind of put in your geographical location, and you can put in some basic information about your solar system, and it will use historical data and provide you an estimate of how much you should produce in June versus July, September, and so on. So having those targets or estimates are also important. And I'll tell you why, because they are estimates, so they're never going to be exact. So you shouldn't, worry about it being exactly dead on. But what it will show you is if there's something that's grossly wrong. So before we actually started this process, we took a look at the solar data and we did a little analysis to see how it was performing. And what we noted is that it didn't seem like it was performing as well as it should be. As it turns out, the solar panels hadn't been cleaned for like 3 years. So we went ahead and did a deep clean on those before we started this kind of reporting period. And that's where it can be extremely helpful, because if you notice something really wrong, like for example, in the month of June, if I was actually supposed to produce 24,000 kilowatt hours, that might indicate there's a problem. Maybe an inverter's out, maybe the solar panels are dirty, so on. And it gives you the opportunity to kind of course correct before you get all the way to your end of your 12 months and say, oh, shoot, I didn't achieve it, So again, it's about identifying issues before, or as quickly and efficiently as you can. So again, we did this, we met monthly and kind of just made sure we were on track. And then we also produced this chart here. So we did figure out what subpanel 1 and 2 were. We found out what all the rest of them were too. So we investigated, and what you're looking at here is basically that same energy use per month, but now we've broken it out by end use. So this is pretty helpful, and this is actually what we used because, as I mentioned, they hadn't achieved net zero in the past, so we knew we had to make some energy efficiency measures or improvements. And so we started here and we looked at which categories had the most energy use. So the darker blue at the bottom is our lighting, and obviously that's the highest category. And then right above it is the lighter blue is our HVAC panel. So that was our second category. So that's really where we started our investigation. And the first energy efficiency measure we implemented had to do with the HVAC. There was a little bit of low hanging fruit. We found out that our heat recovery ventilators were running 24/7. So obviously that wasn't the intent. So we were able to adjust that and put them on the right schedule and get that corrected. And we also noted that the radiant system, particularly in the summer months, had a really high set point. Definitely didn't need to be that high. So we were able to make adjustments, a seasonal adjustment for the radiant system. And ultimately, what you see there is the reduction in that particular category. I know if you kind of take a look, December and January are higher, but what I would tell you for those months is that's when we actually use the radiant heating system or need it, because the heating loads are high. But ultimately, we were able to see that reduction. And again, this was a graph we used with the facility staff. They got used to seeing this, and so they were able to say, oh yeah, look what we implemented, and then actually see the results and be able to read this chart and feel confident in the, because they were really involved in making these changes to the system and these energy efficiency measures. So it was great to have them involved. And then moving on to the lighting system, we made a change not until August here, but ultimately what we found here was that there's a lot of lighting in this library. A lot of it was kind of more decorative than it was for like reading or for a real purpose. But yet all of the lighting was set the same way, and it was set basically to the max output of the lighting fixtures. So we were able to identify a large amount of lighting fixtures that didn't need to be at their full output. And ultimately, didn't cause any problems within the library staff or users of the building. But again, you were able to see that reduction after we made that change. So, you know, what you're not seeing here is I do have an updated chart, and I'm pleased to say that we actually did achieve net zero. So we just finished that up about I'm going to say about 2 months ago. So it was really a great success story from that. But like I said, it wasn't just about achieving zero net energy. It also was about creating a process and a method for the facility staff to understand how to track this and to stay on track, you know, and continue to into the future. And so the last kind of piece of the pie is kind of going back to that dashboard and fixing it. So at this point in time, we haven't quite got that complete, but it's on our radar. And that's one of the last things we want to do to kind of close out this project, is to go back here and kind of make some adjustments. And ultimately, we may land up with some, you know, charts similar to what we produced, but ultimately something that's much more useful and that can help them stay on track for the future.
Quick question for you, Michele.
Sure.
The graph we're looking at, was this produced within the EMS, or was the data pulled from the EMS and then a graph made in Excel or some other data crunching software?
Okay, so yeah, so unfortunately, because as I showed you that dashboard or that graphic of the EMS, it didn't quite have everything the way we wanted it to, and they surely didn't have graphs like this. We had to pull the data. So what we used here, and I'm going to show you in another example, one of the things we've been using, and I pointed out in that LBNL, is this Tableau, because this is something we as engineers can kind of figure out. It's a little bit different than Excel, but it's something that, you know, most engineers could figure out pretty easy with spending a little bit of time around it, and you're able to create some pretty nice visualizations and charts. So ultimately, we pulled the data from the EMS, but we actually did have to generate these, these graphs and outside of the EMS system.
Awesome, thank you.
Sure. But again, our hopes is to actually go back to the EMS and update it and put something like this in there. That's hopefully, again, more useful for them. So that is the kind of final step or intent. But yeah, I think, you know, for this particular project, my key takeaway here is that, you know, they wanted to track for net zero. Their EMS wasn't set up for that. You know, it really does, again, what was their goals, and then configure it in that way. And so that's what needed to happen for them to be able to use it successfully. So this is a good example where, unfortunately, the EMS was not successful because we didn't, you know, kind of understand that when it was being developed. All right, we'll move on to our next one. So again, we're back at LBNL. So this is the one you guys just did the exercise on. And of course, it is a large campus, although I want to talk about a specific building on the campus that I worked on. It's called the IGB. It's the Integrative Genomics Building. Completed in 2019, a LEED Platinum building, 0 carbon. It was not net zero, but it was very low energy intensive building, especially because it was a laboratory. And it is 4 stories, 80,000 square feet. And it also had a very complex mechanical system. It had heat recovery both on the water and air side. It had both water heat pumps, water to water heat pumps, and water to air heat pumps. Radiant in slab, both heating and cooling, chilled beams, and of course a lot of integration with the lighting meters, shades, and so on. So a lot going on there, and the controls sequences in general were really complex. So similarly, I was involved in this project as a commissioning agent, and then as the building got turned over to the owners, they asked me to come back and kind of work with them for the first year of occupancy. And I worked with their ongoing commissioning team that I'm going to kind of talk about in a minute. But ultimately, I was there to help them do a couple things. One, to really understand the building and the design intent behind it, because they never had a radiant system or chilled beams or really heat pumps on their campus before. So it was all very new to them. Also, this, as I mentioned, this client is pretty sophisticated. So one of the things that they did that I've never really seen done before this project was they identified their KPIs, and they had about 20 of them. I mean, they had quite a few. They did it in the design phase. And so we were able to put those on the contract drawings in a nice little chart. And it literally said, I want to measure, you know, the chilled water plant efficiency or whatever it may be. And we said exactly what the metric units were, whether it's tons or, whatever that was. We put in there the exact equation if there needed to be any equations. We talked about, or they put within there whose scope of work it was, if it was provided by the electricians versus the controls contractor. And then they had this little diagram of where the data was going, because they do have, again, multiple systems on their campus. They have an EMS for what you guys saw, the higher level sustainability, and they have a different EMS for their ongoing commissioning team, which I'm going to talk about here in a minute. So it was really effective and helpful during the commissioning process. It allowed us to focus on, and not lose track of what they wanted to measure, making sure nothing got BE'd out, and that all the correct sensors and hardware and so forth and software was there to be able to measure these KPIs. So that was my kind of secondary part on this project, was to help them kind of get those KPIs established and start measuring and monitoring them. But this building, or I should say LBNL in general, has, as I mentioned, an ongoing commissioning team. So it's worth taking a moment to kind of tell you a little bit about that, because this is one of the things that I think they're successful at. And one of the reasons I think they're what I would call like setting the industry bar as far as best practices. So they've established a team of about 7 people, and it's a cross-functional team that includes, again, the sustainability manager. They have facilities engineering involved. They have one of their staff members is actually a programmer. And then, of course, as I mentioned, facility personnel, and maybe from a few of the different groups or trades as well. And so they meet on a regular basis, and then they also have what's kind of like this rolling 30-month or 30-day period where they identify their energy efficiency projects they're going to work on, and then they report on them at the end of the month. And each person kind of gets assigned something, and they go out and they do it. And that's what they focus on, and that's all they focus on. So they're not answering hot and cold calls and so on and so on. But ultimately, they're very good at how they go about this. And they actually taught me a ton of things. And so, as I mentioned, they have obviously a very different energy management system than the one that you just did the exercise on. And they also love heat maps. In fact, they actually create a lot of these types of charts across their campus. So for all buildings, for example, most of their buildings have VAV boxes. And so this visualization, they're trying to standardize across all the buildings that have VAVs. And they find that a couple things that are really important: standardization and visualization. So this is helpful for them in many ways, because these guys get into a routine of looking at this regularly. They know how to read the graph, and they start to understand when there's something different or an anomaly, and it's really easy for them to point it out. So it's about standardization as well as being able to visualize it and point out, again, something that's changed really easy. So that's something that they've really done. And so on their EMS, they also really need the ability to be able to customize and change things. So as we started working on this particular building, Building 91, we noted, well, although there was a few VAV boxes, they had a unique system. They had a radiant system. So ultimately, they were able to customize and create a heat map for all of the reheat or the heating valves in the whole building, or the chilled water valves. So essentially, they're able to do a similar thing, but they were able to customize it for that specific application and unique system. They also do that, for example, as I mentioned, they do their energy efficiency projects. So if they're successful, they will actually come back and make a customized graph to basically not only ensure that the energy efficiency measure worked and that they're saving energy, but that it's persistent. And this is something I've never seen before either. And it's actually located somewhere on that sustainability page you guys were looking at. They are tracking persistent energy savings. And what I mean by that is, just because you implement an energy efficiency measure today doesn't mean 6 months from now that it's still working or that you're still saving energy. Unfortunately, sometimes things can shut off or overridden or something changes. So what I was describing is they will actually create a visualization, a chart, a graph, whatever they want for an energy efficiency measure that they found or they were working on. And that way they can track it for years and years, or months later, to ensure that, again, it was successful and is staying persistent. So I think that's really something that's unique, and I thought was really excellent that they did. So yeah, so again, having the ability to standardize, the ability to customize, and yeah, use visualization was kind of a lot of the takeaways I took from them. And the fact that they created a process around that, right? And so, yeah, it was really, to me, like I said, a great exercise for me to learn a lot about what works and seeing it in practice at a facility. All right, we'll pause here for a second. Any questions right now, Christy?
No, there's none. We've answered them all, so we're good.
Okay. All right. Well, I will keep pressing on here. All right, we got a couple more. So this particular project, it also is a campus, but it's kind of just more of an office corporate complex or campus. The building that I worked on was the one in the center. It's kind of the all glass one there, sandwiched between those two buildings. It was also new construction. And again, I was on the project for the purpose of commissioning. And similar to the Half Moon Bay project, they decided to add an EMS. And they unfortunately also decided to do this late in the construction phase, which ultimately led to some problems. But let me just start by saying why they wanted to add an EMS, because they actually had several EMSs already on their campus, but they really were kind of siloed, right? They had one for their sustainability team, they had one for their facilities team, and then there was a third kind of user involved in there. It was their engineering team. And the engineering team didn't really have a dashboard or an EMS. And ultimately, they were the one driving this project. And they were kind of in charge. They were the ones that were very involved, the engineering group. And bottom line is they didn't really like what they saw out there. They didn't think it had the right tools, didn't have the right visualizations. So they wanted to create a custom one. And another one of their goals was to create one that would encompass everyone, one that not only the engineering would use, but the sustainability team as well as the facilities team. So that's kind of where we went with it. And it was considered a pilot project. You know, they had hopes that we would be able to kind of push this out across their campus and to future buildings and so on. And what I mean from, you know, they built it from scratch. So again, what that means is we didn't buy any prepackaged or any software or vendor product out on the market. We essentially hired a programmer and we told them what we wanted, and they built it for us. And we did use the same, again, I'm going to go back, they used Tableau as well. So it's definitely something that, again, that's kind of easy to make some of these dashboards. So let me go ahead and show you the end result. This is what it looked like. This is not all the pages, but this is a couple of them. So in some regards, we were successful. We obviously had a working dashboard at the end. There were a few things that were not right or not accurate. But at the end of the day, for the most part, we did get a working dashboard. I will say there was a lot of lessons learned. It probably took us twice as much money as we thought, and probably took us 4 times as long as we thought. You know, one of the challenges was the programmer really didn't know anything about the building, didn't know anything about HVAC, and so we had to be able to translate to them what we wanted and what we needed. Now, we did start off with the right intentions, but again, we were late in the construction phase. So I'm going to switch between screens here really quickly. This is something that Redcar produced because we were trying to help them identify their KPIs and who was going to use this dashboard and so on. So we started kind of breaking it apart and saying who's going to use it, what are the things they're interested in, and then we kind of had to go backwards. We needed to make sure we actually had the right sensors and the right things to be able to measure some of the stuff we had identified. But ultimately, we did go through this process of kind of identifying that. And then what we had to do is we had to create what I call is wireframes, which is essentially us just making hand sketch or sketches in like PowerPoint or something, showing exactly how we wanted the data to look, you know, from any of these charts here. And there's some other ones that are like pie charts or bar graphs or whatever that are not shown here. But ultimately, we would literally put it on a piece of paper to show what kind of chart, how we wanted the data to look. And of course, we had to go through with where's the data, what's the point name, where is it coming from, and deal with all of that, as well as any equations and logic and so forth. So it was a very, very laborious process. Like I said, I definitely learned a lot from it, but it was definitely, yeah, a lot of lessons learned. But what we landed up doing at the end is we pulled in the sustainability team and we pulled in the facilities team, and we asked them to kind of play around with the dashboard for a couple days. And then we had a meeting and wanted to get their feedback. And basically what we heard was, yeah, all right, whatever, you know, it's okay, but I'm never going to use it. And actually both parties said that. So that was like pretty disappointing. At the end of the day, what we landed up building was something that was, you know, worked well for the engineers. They loved it. They're like, yeah, this is stuff that I'm interested in, stuff that I look at or track or whatever. And ultimately, we did not build something, you know, that met that goal of one-stop shop for all the different parties or the audiences involved in the EMS. So again, a lesson learned. We unfortunately were not able to kind of pull in those users in the early phases, and as I mentioned, we kind of started late to begin with. But ultimately, that was definitely my key takeaway is, you know, bringing in the right users. So let's pause here and just, we do have a little poll. So if you guys want to participate, that'd be great. You know, what advice could you offer these clients to help them improve their EMS? And this could be, doesn't have to be the last example I showed. It could be any one of them. But yeah, I'm curious what you guys might think. Maybe some ways we could have improved any of those EMSs. What do you need to make it useful? Yeah, definitely asking questions again, asking the right questions, trying to get that information ahead of time for sure. Customize an existing system. Okay. Who'll be using it? Yeah, that's definitely one of the important ones for sure. Definitely in that last example. So yeah, thank you for that, guys. All right. Focus on meeting the needs of the intended user when building an EMS dashboard. Absolutely. I will say it is quite challenging when you have multiple users. It becomes more challenging, let's put it that way. Not impossible, but definitely a little more challenging. All right, we got one last case study here. This happens to be just a small building. It is also on a campus. This particular building has no BMS. I'm not sure when it was built, but it's not that old. They did want to reduce their energy use, and they had a couple questions, but we got engaged with this project from a different way. So it wasn't through commissioning. You know, Redcar does obviously we provide some other services. One of them is just doing research on buildings. We do interact and do a lot of what's called code readiness, where we work with the state of California for the energy codes, and we go into real buildings and kind of see how they're like an energy efficiency measure that is required by the code. We might go in and study it to see if it is implemented the way it was intended, if it's working, and if it's saving energy and how much. We might have some other research questions we're trying to answer, but ultimately, that's kind of the gist of it. So that's how we came across this client. We go out and we sometimes ask clients if they'll participate. It's, you know, no cost to them, but we kind of study their building and their data. So this one became a little bit challenging because we didn't have an EMS or a BMS. So to get the data, we needed to install basically our own sensors. So we used our Internet of Things, IoT devices that got installed, which are quite easy to do and pretty, you know, very flexible, because at the end of the day, we're only needed to measure very specific things. So we went in there with a specific purpose and was able to get those measurements. And then what we did is, you know, we were tracking data and we were kind of reporting. So again, this was something we put together. I actually do believe this this particular Senseware software comes with a software where we were able to kind of do this there. It's not quite as fancy as some of the visualizations you've probably previously seen on some of these EMSs, but it was good enough. And so we were obviously, like I said, doing this for the purpose of research, but we were sharing this with the client. So the client was looking at this and their response was, oh, wow, this is interesting information. I like this. I want to see more of this. So they were really kind of excited. And what you're looking at is the stuff on the right, the lighter shades. Like I said, we weren't measuring everything within the building. So that happened to be what we were measuring. But we were able to put together similar charts to track the overall energy use and obviously those particular systems. The other thing that was interesting to the client was they really wanted to know if this happened to be a VRF system, which is becoming pretty popular as we move towards electrification. And they wanted to know if that system was actually performing as the manufacturer intended, because they were thinking about implementing it into some of their newer projects. So that was kind of their initial interest. But then as they started to see more and more of the data we were providing, they got really interested in it. And they said, can you leave the sensors there? And we were like, no, we can't. But ultimately, there was a discussion that they were going to pursue their own, and they were going to do their own kind of small little energy management system. So to me, this was an example of a couple of things. One, that there are solutions for these smaller clients and clients that don't have BMSs. And two, just because of that, they still wanted to know how their building was performing from, an energy use perspective, and they have the ability to do that. So yeah, also a positive little project. Because ultimately, like I said, there are a lot of there's a lot of existing buildings out there without BMSs or EMSs, and there are cost-effective solutions out there. So that kind of wraps up our case studies. We do have one last kind of exercise here, and I know we have about 10 minutes left. So I would say let's go ahead and attempt it. Maybe we'll be a little shorter here and give it like 5 minutes. I don't think this is very long, but we'll put the link again into the chat. Ultimately, we're going to have you read just a specific section within this manual. I will say, for anybody who finds it interesting, you can download the entire guide here. It is pretty good. It's got a lot of great things in there, but if you could go ahead and try to read the dashboard, the data, and then I think there's a section that says lessons of submetering. That'd be great. And some of the reflection questions we're thinking about is, what are the potential benefits of submetering, and what roles can submetering play as KPI in energy management? And so let's come back in about 5 minutes and see if we have any takeaways from this, and then we will wrap it up and see if there's any outstanding questions. All right, looks like some people are getting through that. So yeah, if you guys were able to get through that and want to participate in this last poll here, that'd be great. Got one comment out there already. Provide granular data for folks keeping track of energy uses. Great. I like, one of the things I really liked out of this article was the section about reaping the benefits of the Hawthorne effect. I really thought it was great that they, again, were sharing with their employees. Not always that common to do. So that was something I really liked out of this particular article. What roles can submetering play in KPI energy management? Yeah, submetering can collect KPI data for sure. It definitely, like I said, gives us another layer of granularity. Instead of just seeing our whole building data, we can see end use, and then even sometimes down to equipment level. So again, it's about being able to get to those opportunities quicker and faster, easier. I like submetering the end uses. Like I said, that's something we typically, how we approach a zero net energy building is seeing where most of the energy is being spent. That's usually where the most opportunity is. Not always, but usually. So to me, it's a helpful starting point on how to approach it. But yeah, as you guys are kind of wrapping up, if there's any other additional questions, feel free to put them in the chat. And we will start kind of wrapping up here. Hopefully today, and through our last class, we have answered the questions of what an EMS is and how to successfully implement and use one. So I do hope we did answer that for you guys. And I, again, definitely appreciate everybody's participation. And I don't know if anybody else wants to jump in here. Any other final announcements to make?
We don't have any more questions, so I think you've answered them all either in like presentation or outright. I do have one question for you actually, because I've heard you talk about a lot of different tools that you're using, and I was wondering what your favorite tool to use. Like you said, you were using and I want to call it Trello, but it's not, the graphing software, Tableau.
Oh, yeah, Tableau, yeah.
Yeah. So do you have others that you really use often?
Well, we have recently, and I'll be honest, this is more on our research side than maybe in the commissioning part of our business, but we have been using another programming tool called Python, and that is a way for us to bring in large amounts of data from maybe different buildings, different building management systems, because we're collecting a lot from different clients. And so this is a way for us to kind of, what I would call kind of clean the data, making sure the timestamps and everything kind of lines up, and there's not missing data, things like that. And we're able to write these little kind of scripts to kind of make our work a little bit easier. So that's something we're doing on the analysis side. There are, like I said, there are other softwares out there that do this, or that you can buy kind of pre-packaged to do some of this stuff. But we like the ability to be able to write some of this ourselves. And I think we see it as a tool maybe we can evolve and maybe create some more useful things out of it. But I would say we're just kind of dipping our toes into it. But Tableau has been the one that we've been using most recently in the last year or two. And we used to use Excel, in all honesty, and it just became too slow, and it couldn't handle the massive amounts of data. So that is kind of really our reasoning. We kind of almost got forced into it, but ultimately really liked it. And it was also a great tool, not only for handling that large amount of data, but like I said, it's really great for making some really nice graphs and charts, which is always the best way usually to present information to a client. So yeah.
Cool, thank you. Well, that's it, and we're at time, so I think it's a thank you to everyone who is here and participated in the interactives. Really appreciate that, that polling, that survey, those textural pieces. Really appreciate your participation. And Michele, thank you so much for hanging out with us today to present. I don't know if Katie is back there. Katie, are you around from SCL?
Yes.
Awesome. Do you have some final words for us?
Yeah, just want to thank everybody for coming, and lightingdesignlab.com is our website, lightingdesignlab@seattle.gov if you have any questions after, in the next couple of days. And this will be posted, the recording will be posted to our website within about a week.
Oh, fantastic. If there's a couple people who are still out there and want to log or hop on to this exit survey, we would be super appreciative, but we also want to honor your time. So if you need to go, you are more than welcome to. We'll hang out here for another 2 or 3 minutes, probably to about 12:05, and then we're going to hop off as well. Remember that there are more classes with DNR and SCL happening. The heat pump one is coming up. Really excited about that in a couple of weeks. And then there's electrification of the built environment. 2 amazing classes worth checking out. Michelle, do you have any big plans now? You're all done for the day, at least with that.
Oh, I wish. Unfortunately, not quite. Oh, yeah.
I think we had a great class. I always learn something when I get to hang out as a moderator, and I really appreciate that. And I really like. I'm going to toot our own horns, Michelle. I really like all the examples that are in this second half of the deck. Like, it's really cool to get to hear you talk about projects you've worked on.
Yeah, I mean, it's still a challenge out there. I'm not going to deny that. I mean, like I said, I think things are changing, more tools, more this, more that. Probably not at the rate that we would like or need, but yeah, it's still, to me, it's still fun in working through those challenges, and everything, every building and every system's usually a little unique. So definitely enjoy it.
Well, I think we're all out of attendees. Travis is the last to log off. Not to name names, but hey, Travis, you're welcome to go. I think we could probably log off too. Ladies, thank you so much for a fantastic course.
All right. Thank you.
Thank you. Bye.
Bye.